working for both. What's 2 plus 7? 9. 27, right? 9. Count by 3, 6, 9. See how 3 fits into a 9? What is 3 plus 0? 3. Count by 3s, 3. Well, that's all I need to do is go up to 3. 3 works for both. So it's a little trick you can use. And you know a 3 is going to work. Now, how many times will 3 go into 27? 3 times what? 3 times 6, 3 times 7, 3 times 8, 3 times 9. 3 times 9 is 27. So 3 times 9 is 27. So how many times will 30 go into 3? 30 divided by 3 is 10. So I got 9/10. Now how do I know this is right? They're equivalent to each other. So if you cross multiplied these two, you should get the same number if you did that. And I'm pretty sure you would, because 9 times 0 is 0. 9 times 3 is 27. You get 270 if you cross multiplied. 10 times 27, add a 0 to the 27. You get 270 for that part. And guess what? It's equivalent. Its simplified version, though, is a 9/10. So the first part of this is 9/10. So now that part's done right here. So I've got this next part right here, 18 divided by 3. You cannot do a problem like this if it's division. But here's an easy trick. You can keep, change, flip. It's so easy if you'll just practice. That's also called reciprocal, by the way, reciprocal. So right here, you have 18, but if there's not a number under the number, you got to put one under it. And what would go under the 18? Well, obviously a 1. So I'm going to rewrite it. 18 over 1. All numbers have an invisible 1 under them. It's a fraction. 18 over 1 is 18 divided by 1, which is really just 18. So now you change this always to a time sign right here. And you flip. Reciprocal of 1/3 is 3 over 1. And you're going to end up having to multiply. This is not cross multiply. It's regular multiply. So 1 times 1 is 1. And this is 18 times 3. So I'm going to do 18 times 3, maybe up here. And I'm going to do 8 times 3 is 24, carry a 2. 3 times 1 is 3, plus 2 is 54. I think I did that right. 8 times 3, 8, 16, 24, carry a 2. Add the 2 there, you get a 54. So it's 54 over 1. So as you do this problem here, you're going to have a 54 over 1 equals 54. So far now I have plus what? 54. So 54 is what I've got so far. But could I put a 1 under that if I wanted to? Yes. So as I continue the problem, on this part right here, I would cross multiply. Right, not cross multiply. Sorry, I'm being interrupted while I'm doing this, so I need everyone to pay attention. Let me do this. So this is where I would triangle it. So right here, you would not cross multiply, you would triangle it. This is so easy. It's always the same thing in math. You just repeat the same steps. Do this, make a triangle, put a times, and put a plus sign. 4 times 5 is 20. 20 plus 1 is 21 over, leave the 4 the same. So you always multiply, add, leave the same. 21/4. Well, you can't have 21/4 because if it's improper, when it's bigger on top, you have to what? Divide. So how many times will 4 go into 21? You got to fall to the right to get it right. So 21 would go right here. And you would put the 4 there. Remember, the numerator falls to the right. Denominator's down, numerator's north. Get it? So, how many times will 4 go into 21? I'm going to put a decimal 00 in this case. 4 will go into 21. 4 will go into 2. I'm going to go quick on this, but you can rewatch this. 4 will go into 2. 0 times. 0 times 4 is 0. 2, bring down a 1 because you subtracted. Daddy, mother, sister, brother. Divide, multiply, subtract, bring down. So 4 going to 21, 4 times 5 is 20, subtract, you get a 1, bring down a 0. 4 will go into 10 2 times 4 is 8, subtract, you get a 2, bring down a 0. Remember, you can rewatch this as much as you want. 4 going to 20, 4 times what? 4 times 5, so you get 5.25. So you get plus 5.25 right there. Now I'm almost done. 18 over 6 is improper. What's 18 divided by 6? Remember, fall to the right. Put an 18 in here, but you could do that in your head if you think about it. 18 divided by 6 is 3. And it leaves me with 12 over 18. Remember, you need to simplify this. This is not improper, but it needs to be simplified. It used to be called reducing in lesser terms, lower terms. What could go into a 12 and an 8 besides a 2? What about a 3? Because 1 plus 2 is 3. 1 plus 8 is 9. Yeah, 3 would work. What about bigger? What about a 6? 6, 12, 18, you can skip count. 6 would be the biggest you could probably use. So you would do this. 6 will go into 12 one time. 6 will go into 18 3 times. You get 1/3. So now I've got plus 1/3. Now, when I'm done with this, I can start adding it all together, right? But remember, I would do this first and get a common denominator. Then I would add this to your answer, whatever you get. Then I would add this to that answer, and then I would add this at the end. You could probably transform that to a decimal, like decimal 33, couldn't you? That's why you need to memorize your fractions. Like 1/3 is 33 cents approximately, decimal 33, 1/4 is decimal 25, etc. In other words, you could fall to the right again, the numerator, 1.00 divided by 3, and you would get approximately decimal 33 if you rounded it. So I want y'all to actually work this out yourselves and see what you get. But this is the main point I was trying to make on how to solve with different types of fractions. The end.